Welcome you all to the second session of Special Theory of Relativity. I am Sunil Ement, Assistant Professor of Physics in Government First Grade College, Ranebennur. So in this session we are going to study the Michelson-Morley experiment, which was conducted to prove a hypothetical medium or an inertial frame of reference in the universe, which was conducted in 1907 by two American physicists, Michelson and Morley. Here, this is a picture of those two physicists. The prerequisite thing before going to this session are again frame of reference, dynamics of a system, mass, velocity, acceleration and those things, and especially the interference of light. On the basis of interference of light, they conducted this experiment to prove an hypothetical medium called ether. Let us see what is that. The ether hypothesis, that is hypothesized medium. It was an imagined medium, not a real medium. The points of ether hypothesis are: ether was a hypothetical medium in which light wave travels. We know that sound requires a medium to travel from one point to another point. Similarly, they were imagined that light also required a medium to travel from one point to another point. That medium is called as ether. Ether exists everywhere in the universe, even in vacuum. So existence of ether was undetectable, but it was imagined that it is present everywhere in the universe. Even in vacuum it is present. Ether must have very large elasticity and low density. Michelson-Morley experiment was set to find this hypothetical medium. That was the aim of the experiment. The aim of the experiment was to detect the relative motion between ether and the earth. The first thing is they wanted to determine that hypothetical medium and the relative motion of that medium ether with respect to our earth. Michelson-Morley experiment did not find any hypothetical medium like ether. So this statement suggests that the experiment was failed, or it gave null result. So Michelson-Morley experiment. This was the ray diagram of Michelson-Morley experiment. Let us see what are the things we have in this diagram. Here, S is the source of light. A ray of light falling on a plate P, which is called a semi-silver plate, which is inclined at an angle of 45 degree. When a light falls on this plate, half of it is reflected and half of it is refracted. The reflected ray move along the point B, or it is a mirror. A mirror named as M1, which is placed here, and another mirror M2 is placed at a point A. Here B dash and A dash and P prime, or B prime, A prime or P prime are the imaginary, or some of the points, imagined points of P, B and A respectively. When light ray falls on the plate P, some of the part is reflected towards B. After reflection, it moves again along P and transmitted through this glass plate and reaches the telescope T. So another part is transmitted through this glass plate and move along PA, which reflects by this mirror and again come back in the same direction and reflected at the plate P, and which will be collected in the telescope. So due to the phase difference between these two rays, we get a fringe width. On the basis of this theoretical thing, they wanted to prove there will be a medium called ether in the universe. Here M1 and M2 are mirrors. P is traveling microscope. S is source of light. P is semi-silver glass plate inclined at angle 45 degree. The whole system or the whole apparatus is moving with a constant velocity v. The experimental setup is done like Pa is equal to Pb is equal to D. The distance between the two mirrors from the semi-silvered plate P are equal. That is Pb is equal to Pa. The velocity of light along Pa is taken as c minus v. The velocity of light means light is traveling from the point source S towards in this direction, and also the operators or the earth is moving in the same direction. This operators is moving with the velocity v, so we can subtract that velocity by the velocity of light. We get the velocity of light along this direction is c minus v, and velocity of light in the opposite direction, that is a to p, is equal to c plus v. Another thing is that when light move from point P towards B, during the duration, means when light starts from here and reaches this point, the B point is shifted to B prime. So the light from P falls on B prime, not on B, and it reflected back to P prime, not on P. So these make a triangle which is separated by another line CB prime. So here we have two right angle triangles. Using the geometry here, we are going to prove the fringe shift or the time taken by the light to travel this distance. Here, time taken by the light to travel P to A is equal to the distance by velocity, that is d by c minus v along the apparatus. The time taken by the light to travel A to P, that is in the reverse direction, is equal to d by c plus v. Adding these two, we get total time taken by the light is T is equal to 2d by c square plus c square minus v square. And so doing some algebra and using binomial expansion, we get T is equal to 2d by c into 1 plus v square by c square. Call this as equation 2. So this is the time taken by the light move towards A and revert back to P. If T1 is the time taken by the ray from P to M1, that is if we take T1 as a time taken by the light ray to move from the semi-silvered glass plate P towards the mirror M1 which strikes at B prime, then PB prime is equal to C1 into T1 and BB prime is equal to V into T1. Here total path of the light ray is P B prime P prime, which is equal to one side of the triangle PB prime plus other side of the triangle B prime P prime, which is equal to 2 PB prime. It is said that it is an isosceles triangle, so we can write that as PB prime is equal to B prime P prime. So in the next step we get PB using this theorem, PB prime whole square is equal to PC whole square plus CB prime whole square, which is equal to PC is equal to BB prime and CB prime is equal to PB prime. So already we have shown that B prime is equal to V T1, PB is equal to D, and PB prime is equal to C into T1. So we get an equation C square T1 square is equal to V square T1 square plus D square. Simplifying for T1 in this equation, we get T1 is equal to D by C square minus V square. The total time travel in the whole path B prime P prime, that is the light ray start from the semi-silvered plate P, move towards the mirror M1, hit at the B prime, and again reflected to the point P1. To travel this distance, the time taken by it as T prime, which is equal to 2 times of T1. So I multiply 2 by this equation, we get 2d by root of c square minus v square. Using binomial expansion, we can write this as 2d by c into 1 plus v square by c square. Call this as equation 2. Compare equation 1 and 2. We have only one part, that is here. They are similar in all the terms, but in this term, in the denominator, we have here c square. Here we have 2c square. So we can say that t prime, this is less than t. So in the next step, comparing equation 1 and 2, we said that t prime is less than t. Therefore, the time difference, we can take time difference, take it as a delta t. Delta t is equal to t minus t prime, which is equal to dv square by c cube. Subtracting t prime by t, we get this equation. The distance traveled by the light during this interval, which is equal to the velocity of light c into delta t, that is the time difference here, delta t. So c into 1 by c cube, we get c square. So the distance traveled by the light during this interval is dv square by c square. The whole apparatus was rotated by 90 degrees. So this was the result, and the distance traveled by the light was measured as dv square by c square. Then they did one thing. They rotated the whole apparatus by 90 degree to find the path difference in terms of fringes. Michelson-Morley expected that they conducted very accurate experiment, that is their apparatus was floating on the mercury. Even a small change in the earthquake or any other thing, it will be able to measure that thing. But even the sensitive experiment could not find any fringe shift. They were expected about 0.4 in the apparatus when it is rotated, but there was no fringe shift was observed. But in the experiment, no displacement of the fringes were observed, means a fringe shift was not present. Even the experiment was conducted at the different points on the Earth's surface and the different seasons and different altitudes also. Whole the year in 1907, it gives null result. So that is, they concluded that it is impossible to measure the speed of the earth relative to ether. So the final result of that experiment, ether was undetectable. They were failed to detect that medium ether. No, so result, they were written the result like this: no such medium like ether exists. That's it for the day, and the Michelson-Morley experiment was concluded. Recap of this session is: we have studied the ether hypothesis, construction and working of Michelson-Morley interferometer, observation of Michelson-Morley experiment, failure of Michelson-Morley experiment, and ether hypothetical medium doesn't exist. This was the final statement of Michelson-Morley experiment. Some of the reference books to study the special theory of relativity are here. Thank you all.